The reduction of organic functional groups. Let's begin by reviewing the oxidation, the reverse process of a primary alcohol. We've seen this in an earlier program. A primary alcohol, when subject to an oxidizing agent, is converted into an aldehyde, and then further oxidation, or heating under reflux, we produce a carboxylic acid. Reduction is the reverse process using a reducing agent. Let's begin by examining what changes occur to the oxidation state of that terminal carbon. Recall, the oxidation state is the apparent charge an atom gets if the most electronegative atom takes all the electrons in a bond. So beginning with our carboxylic acid, that terminal carbon will lose electrons to oxygen because it's a more electronegative element. The fact that there are 3 bonds indicates there's been a loss of 3 electrons from that carbon. Hence, it has a +3 oxidation state. When we move to the aldehyde, we have a doubly bonded oxygen, so that's going to remove 2 electrons from the carbon. Carbon, however, is more electronegative than hydrogen, so it gains 1. The net effect, it's lost 1 electron, hence the +1 charge. And finally, in our primary alcohol, the oxygen will take 1 electron because it's a single bond. However, it gains 2 electrons from the hydrogen, hence the net gain of 1 electron and the oxidation state of -1. We can see that the oxidation states are getting smaller. This is indeed reduction. What happens with a secondary alcohol? Under oxidation, a secondary alcohol is converted into a ketone. So again, reduction is the opposite process. I've provided here the changes in oxidation state to verify that this is indeed reduction. A little bit now about what the reducing agents are. There's really 2 of them. One, a very strong oxidizing agent, that's the lithium aluminum tetrahydride. And sodium boron tetrahydride is also a reducing agent, but not as strong. If we want to convert a carboxylic acid to an aldehyde, we require the stronger oxidation agent, the lithium aluminum tetrahydride. However, we can accomplish all the other reductions with the weaker form. Reduction also occurs with unsaturated compounds being converted to saturated compounds. Here you can see the conversion of ethene to ethane by adding hydrogen. This is also referred to as the process of hydrogenation. Let's begin by examining the changes in oxidation state. The terminal carbon has gained 2 electrons from the hydrogen, hence it has a -2 oxidation state. When it becomes saturated, that carbon gains 3 electrons from the 3 hydrogens and becomes -3. It's become a smaller number. So again, this is also reduction. Overall, here's what the equation looked like. And I'm also going to write their oxidation states above each of the elements. Again, just confirming that the carbon has been reduced. In this case, by the reducing agent, hydrogen. During the process of becoming saturated, carbons become reduced. Let's see if we can determine, in this case, what would be the reduction product of the following. Well, noticing the double bond, it's not a saturated compound, and also being cyclic, it's not a saturated compound. When this becomes saturated, it's going to have 4 carbons, essentially with all of them containing 2n+2 hydrogens. Here we can see the changes in the oxidation states of the carbons in the cyclic compound when they become saturated. Let's try a few questions on these topics. First off, deduce the reduced products of the following compounds. The first compound you might recognize is the benzene ring, and its formula C6H6. When this becomes saturated, it's going to form hexane, a 6-carbon chain, again using the 2n+2 rule to get the number of hydrogens. So that would be the most reduced form of our benzene ring. What would be the reduction product of this? Well, the first thing you should do is recognize that's a carboxylic acid. And if I reduce it, the first thing it would be turned into would be an aldehyde and then ultimately an alcohol. In this case, a primary alcohol, because it's forming a carboxylic acid, so I would expect the following formation with propan 1-ol. Give us a like if you found this useful. Thanks for watching.